Welcome, learner, to today's deep dive. I am really excited about this one. We are getting into some excerpts from Joy Buolamwini's book, Unmasking AI. And the mission for today is to really figure out how these supposedly hyper-advanced, totally objective machines are, quietly inheriting our deepest human biases.
It's a massive topic. And her book really pulls back the curtain on things we just interact with blindly every day.
Right. So to start us off, I want you to imagine looking into one of those smart mirrors. You expect to see your face with some cool digital filter, but the computer just refuses to acknowledge you even exist.
Just total blank screen.
Exactly. It doesn't track your eyes. It doesn't map your jawline, nothing. But then you pick up this literal, featureless, blank white plastic Halloween mask and hold it up.
And boom, it works.
Instantly. The detection box snaps right into place. The machine registers the plastic mask as human, but your actual living, dark-skinned face registers as nothing at all.
What's fascinating here is that this wasn't just some hypothetical thought experiment. That exact scenario happened back in 2015.
At MIT, right.
Yeah, in MIT's Media Lab. They literally call it the Future Factory. Joy Buolamwini was a graduate student there building this Aspire mirror for a class project.
Oh, to project Serena Williams' face onto her own reflection, I think.
Right, using half-silvered glass and face-tracking software. And when it couldn't detect her dark skin, but perfectly recognized a white plastic mask, it wasn't just some quirky technical glitch in a student project.
No, it was like a massive red flag.
Exactly, it was a symptom of a systemic issue, where technology actually reflects the priorities and prejudices of its makers. We're talking about the gap between the utopian promise of AI and the very biased reality of the algorithms shaping your world right now.
Okay, let's unpack this, because whenever researchers bring this up, there is always pushback. You see it in internet comments all the time. People saying, oh, algorithms can't be racist. It's math. It's just the laws of physics, or maybe just bad lighting bouncing off dark skin.
I hear that defense constantly, but it completely ignores the historical roots of how we even taught machines to see. The camera has never been a truly objective observer.
Right, because there's this great analogy in the text about analog film, the Kodak Shirley card.
Oh, the Shirley card is such a perfect example of this.
It's wild. So basically, back in the day, analog film had to be calibrated, right? The photo labs needed a baseline image to set the chemical exposure. So they literally used a picture of a white woman with fair skin.
Named Shirley.
Named Shirley. And that card became the universal default for the entire global photography industry, which meant the chemistry of the film itself was formulated to capture light skin.
And if you had dark skin, the film physically lacked the dynamic range to render your features. Not because of physics, but because defaults are not neutral.
Exactly. And the craziest part is why they finally changed it. It wasn't because they wanted better portraits of black people.
No, it was corporate complaints.
Right. Furniture companies and chocolate companies were mad that the film wasn't picking up the dark brown tones of their wood grain and their chocolate in advertisements.
That is exactly how the author explains the concept of the coded gaze. You know how media scholars talk about the male gaze or the white gaze?
Yeah, like how movies are shot for a specific audience.
Right. Well, the coded gaze is that same idea applied to tech. The preferences of those in power are baked into the code. Those historical exclusions in physical analog cameras were just directly inherited by modern digital sensors.
Which means all the billions of digital photos we take are fundamentally skewed from the jump.
Precisely. And that brings us to how machines actually learn from those skewed images.
Because we don't program computers the old way anymore, right? Like the old rule-based programming where you had to manually type out every single rule.
Yeah, that was way too brittle. You can't write a rule for every single lighting condition or facial feature. So the industry shifted to machine learning.
Right, neural networks. And the book has this amazing way of explaining them using marshmallows and toothpicks.
It's such a helpful visual.
Yeah, so imagine a giant web. The nodes in the network are marshmallows. And the weights, like the connections between them, are toothpicks.
And those toothpicks get stronger as the machine learns.
Exactly. You feed the machine thousands of images, and when it recognizes a pattern, the toothpick gets thicker. It's not learning rules, it's just recognizing patterns in the training data.
But that relies entirely on the data you feed it. And this introduces the concept of power shadows.
Power shadows, I like that term.
It basically means that societal hierarchies, like patriarchy or white supremacy, literally cast a shadow over our data. Computer vision relies on these massive labeled data sets, like ImageNet, or one called Labeled Faces in the Wild, LFW.
Which was like the gold standard, right?
It was. For years, if you made a facial recognition system, you tested it on LFW. But the stats on that data set are shocking. It was 77.5% male
Oh, wow.
and 83.5% white.
So it's basically just a pale male data set.
Completely. And if we connect this to the bigger picture, when you train your neural network exclusively on that kind of data, you end up with the AI functionality fallacy.
What does that mean exactly?
It's a trick of the mind. The machine looks incredibly accurate and advanced, but it's really just highly optimized for one specific demographic. It works perfectly for white men, so people assume it just works perfectly.
Here's where it gets really interesting, though, because on paper, these giant tech companies like Microsoft and IBM, they were boasting that their systems had nearly 90% accuracy.
Or even higher. Yeah.
Which sounds amazing, but that overall aggregate accuracy is just a mathematical smokescreen.
Because aggregate data hides who is actually failing.
Exactly. So the author did her own audit. She created the Pilot Parliament's benchmark, and she specifically used photos of politicians from countries with really high gender parity in government, like Rwanda, Senegal, and Nordic countries.
So she had a truly balanced data set to test with. And she applied Kimberly Crenshaw's legal theory of intersectionality to it.
Right, because you can't just look at race or gender in a vacuum.
Exactly. You don't just test men versus women or light skin versus dark skin. You combine them. So she broke the data into 4 quadrants: light-skinned males, light-skinned females, darker-skinned males, and darker-skinned females.
And the findings in her Gender Shades project were just devastating. For light-skinned men, the accuracy was basically 100%.
Flawless.
But for darker-skinned females, total failure. IBM had a 34.4% accuracy gap. And for the darkest skin types, the error rate was up to 46.8%.
It was basically flipping a coin.
Yeah, a coin toss on whether a dark-skinned woman was a man or a woman, which is wild. So what does this all mean? Like, the algorithms are obviously only as good as the data, but it gets into this weird philosophical territory about who gets to label the data in the first place.
Oh, absolutely. The concept of ground truth in AI.
Right. It sounds like humans playing God.
Right.
The author had to use the Fitzpatrick skin type scale to categorize the faces, but that scale originally only had categories for white skin.
Yeah, it was developed for dermatology to see how fair skin reacted to UV light. It wasn't meant for everyone.
And then to even run the audit, she had to force every face into a strict male or female binary, because that's how the systems were built, which completely erases trans and non-binary people right from the start.
It's a very messy, subjective process. And this raises an important question regarding consent and privacy. How do these companies even get millions of photos to train their systems?
They just scrape them off the internet, mostly.
Right. It's this standard of lawful yet awful. Researchers just harvest images without asking. The text talks about the MIRE dataset using photos of deceased inmates.
That's so dystopian.
Or IBM using almost 1 million photos from Yahoo's Flickr. People's personal vacation photos just fed into a corporate machine.
And we saw this blow up recently with Lensa, right? Those magic avatars.
Yes, exactly.
Women were uploading normal selfies, and the AI was generating these hypersexualized, sometimes nude images of them, because the model was trained on unconsented art and weird internet images.
And this is why the author argues that just deleting the stolen images isn't enough. If I complain, a company might delete my photo from their server. But the algorithm has already learned from it. The toothpick is already thicker.
So that's a solution.
Deep data deletion.
Yeah.
You don't just delete the image, you have to delete the entire AI model that was built on top of that stolen data.
Wow. Just scrap the whole thing. I love that, actually. But you know what really gets me about all this? It's the contrast between what Silicon Valley thinks is dangerous and what actually is dangerous.
The obsession with long-termism.
Yes. All these tech billionaires freaking out about X risk. You know, the idea that a super intelligent AI is going to wake up in 100 years and turn us all into paperclips.
Very convenient distraction.
Totally. They worry about hypothetical future humans while ignoring the actual harms happening today. Like, the author did this spoken word piece called AI, Ain't I a Woman?
That was a powerful counter demo.
She showed how the AI literally misgendered Serena Williams. It said Michelle Obama was wearing a toupee. It couldn't even find a young Oprah Winfrey's face.
And while seeing it fail on celebrities makes a great visual, the real stakes for the listener are about being excoded.
Excoded?
Right, being algorithmically excluded or harmed. It means being wrongfully arrested because a facial recognition system mismatched your face on a grainy security tape.
Like what happened to Robert Williams, arrested on his own lawn.
Exactly. Or it means being flagged for cheating by e-proctoring software. Say you have a motor disability, or you just look away from the screen to think, the system decides your movement isn't normal and flags you.
Just because you don't fit the pale, able-bodied default.
Or having your resume thrown in the trash by an Amazon algorithm.
Yeah.
They built a hiring tool that actively penalized resumes with the word women's on it, because historically their successful hires were men.
It's literally automating sexism.
Yes. When you just parachute these tech solutions into communities without understanding the context, you aren't fixing anything. Unchecked AI just scales structural violence.
It just does it faster. Okay, so we've covered a ton of ground here. But if there's one core takeaway for the deep dive today, it's that AI is not some magical, objective judge of truth. It is literally a mirror. It reflects our aspirations, but also our limitations and all those historical power shadows.
It only knows what we teach it.
Exactly. And to you listening, you are part of this ecosystem. Every time you upload a photo, every time you apply for a job, you are interacting with these neural networks. You have every right to demand algorithmic justice and hold these tech giants accountable. They are building our digital infrastructure.
And we shouldn't just accept a broken foundation.
Right. So I want to leave you with one final thought to mull over. We've established that machine learning strictly requires vast amounts of historical data to even function. It has to learn from the past. But if human history is inherently filled with bias, discrimination, and inequality, is it even mathematically possible to build an AI that is more objective than we are? Or will our pursuit of the flawless machine always just be haunted by the ghosts of our own human flaws?
That is the million-dollar question.
It really is something to think about. Thanks for taking the deep dive with us today.